In this short video, I briefly describe the posterior distribution in the regression model in that uses the output provided by JASP. So on the left-hand side, we've got the four models. The first one is the model of the null hypothesis. The second one is the model in which only group practice is a predictor. The third is a model in which only individual practice is a predictor. And in the fourth, both group practice and individual practice are the predictors. On the right-hand side, we've got the posterior distribution, which is a probability distribution over the possible parameter values. What parameters are we talking about? We are talking about the beta coefficients of the regression. So on the top is beta 1 because that's the slope that corresponds to group practice. That is, that it identifies the number of points in national rating that would increase by an increase of 1 unit in group practice. So in that distribution on the top, we've got group practice. The mean of group practice is 0.014, and the credible interval of that distribution goes from 0.00677 to 0.0208. So that is the posterior distribution of the beta 1 coefficient, and it gives us a 95% confidence interval, or credible interval, like we call it in Bayesian statistics. And well, one of the things that is interesting is that the mean is greater than 0 and the whole interval is greater than 0. So we've got strong confidence that in the population the slope of this regression model, the beta 1 slope, is positive. On the bottom of the figure, we've got the posterior distribution over beta 2. Beta 2 is the slope of the regression that corresponds to individual practice. And as the group practice one, it is the number of national rating points that would increase by the increase of 1 unit in individual practice. And we've got the distribution and the 95% credible interval. And the mean of that distribution is 0.002, and the credible interval goes from minus 0.000429 to 0.0119. So the interesting thing of this distribution is that the 95% credible interval includes values that are 0 or lower. So we don't have a strong credence as we have with beta 1 that this is a positive slope in the population. Although most of the distribution tells us that it's positive, there is still some probability that it is not, that is negative, or even 0. So this is what tells us the posterior distribution. Now, you may wonder that why I'm presenting only one posterior distribution for beta 1 and one for beta 2 when we have 4 models, and each of these models has a posterior distribution for the parameters. So why I'm not showing one distribution per model per parameter, so 8 distributions? Well, I'm using a feature of JASP, which is model averaging. And it's a quite interesting feature, which is that it calculates the posterior distribution of the models, and in this case, the posterior distribution for the null model is very, very low. and the one for individual practice only is also small. But the one for group practice and the combination between group practice and individual practice, they have the highest probability between the two. They've got um, um, close to 100%. So what it does, it takes it does the posterior distribution of all these models, and it takes an average of that, and that average is the one presented here. Now that average is not dividing by 4, it is dividing by the weight that each of the model has. So the group model, which is the one with the largest posterior probability, has the most weight, and the one with a group and individual practice, which is the second one, it has the second strongest weight, and the other two contribute very little. But the contribution between the two main models is what it creates this posterior distribution with model averaging.